Hi fifth graders, it's Mrs. Trombley here. We are going to kind of go back just a little bit. We were in Unit 1. We've covered a lot of different units already in math, but we decided to save the best for last, fractions. So before we left, we were working on adding and subtracting fractions. And before we started that, we looked at representing fractions and equivalent fractions and unit fractions. So the goal of today is just to review the first 2 lessons of the chapter. At any time you can pause, rewind. This video is not going anywhere, so you can come back to it if you need to, but I'm just going to kind of walk you through what we've learned so far. All right, so lesson 1, representing fractions. There's 4 main ways people represent fractions. You can look at fractions as parts of a whole, parts of a group. You can use a fraction bar to represent, and you can also represent it on the number line. So I'm just going to go ahead and kind of take you through each of those, and we're going to use 3/4. So in the fraction 3/4, 3 is the numerator and 4 is the denominator. The denominator tells you how many equal pieces the whole is divided up into. So when I look at 3/4, 4 is the denominator. That 4 tells me how many equal sized pieces the whole is being divided up into. The numerator tells me how many parts I'm using out of those 4. So with 3/4, if I wanted to show you equal parts of a whole, I chose a circle and a square. So look at these as 2 separate things. For this circle, if I wanted to show 3/4, my first step would be to divide this up into 4 equal pieces, like that. And we want the pieces to be as close to the same size as you can get. And to show 3/4, I would just shade 3 out of those 4 pieces, and I can shade any 3 that I want. Same thing for a square. I can divide the square up into 4 equal pieces. I could have just drawn 4 lines this way or 4 sections that way, and then 3/4 would just be shading 3 of those. So that's equal parts of a whole. The circle representing the whole amount, cut up into 4 pieces, 3 are shaded. The square representing a whole amount, cut it up into 4, 3 are shaded. You can also represent fractions as parts of a group. So in this, I don't have just one shape. I have 4 little smiley faces. So there's 4 in the group. 3/4 of that group would mean 3 out of the 4. So that's how you would show a fraction as parts of a group. Fraction bars are just very similar to parts of a whole, but it's just one rectangular bar that's shown. To show 3/4 on a fraction bar, I would cut the bar up into 4 pieces, because remember that denominator tells me how many pieces there are in the whole. And then 3/4 would mean I'd have 1/4, another 4th, and another 4th. So those all together equal 3/4. And last but not least, we have our number line. And notice on this number line, it's only going from 0 to 1. We have amounts in between 0 and 1, and that's where those fractional amounts come in. So if I wanted to show 3/4 on this number line, I would need there to be 4 equal sections between the 0 and the 1. The denominator tells me how many sections. So in order to make 4 sections, I need 3 lines. 1, 2, 3. And I always do a quick count just to make sure that there are 1, 2, 3, 4 sections. Again, that denominator tells me. And to get to 3/4, I would start at 0, and I need to hop 1, 2, 3 sections over in order to get to 3/4. All right, so let's try a couple of examples. Example A says, what fraction of the shape is shaded? So maybe right now, if you have a whiteboard, or if you have just a sheet protector with a blank piece of paper in it, or even just some lined paper, if you wanted to kind of jot down what your guess is as we go through these, that would be helpful to think about it beforehand. And you can always pause if I'm going too fast. So for letter A, what fraction of the shape is shaded? Well, let's see here. There are 1, 2, 3, 4 pieces shaded. That's the amount that I'm using, so that's my numerator. The denominator is how many pieces this whole circle is broken up into. It's not broken up into 3 pieces. It's broken up into 1, 2, 3, 4, 5, 6, 7 pieces. So 4/7 of the shape is shaded. For B, what fraction of the stars are not shaded? So with this, I want to look at the ones that aren't shaded. Those are the ones I'm counting. The ones that aren't shaded will be my numerator, and I see that there are 3 that are not shaded. out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 stars. So again, the number that I'm counting is my numerator. The total number of stars that there are is my denominator. Letter C, what fraction of the triangles are outside of the circle? So the ones that are outside, those are the ones that I'm counting. Those would be my numerator, 1, 2, 3. And my denominator is going to be the total number of triangles in this picture, which are 1, 2, 3, 4, 5, 6, 7. So 3/7 for letter C. Letter D says, locate 3/5 on the number line. So right now there's a 0, there's a 1. I want to show 3/5 on this number line. That means I need 5 sections between 0 and 1. So that means I'm going to need to draw 4 lines in order to get 5 sections. I'll do my best. I'm working in pen. It would be better for me to be working in pencil, but it's more difficult to see. I'm going to do my best to draw 4 lines. Well, not too bad. And that one's a little smaller than the rest. We want them to be the same size. But there's 1, 2, 3, 4, 5 sections between 0 and 1. 3/5 would mean starting at 0 and hop over 1, 2, 3 of those sections. So 3/5 would be right there. And again, if you're wanting to try these on your own, all you have to do is press pause. And then once you finish, press play again, and then you can see what the answer is. Right, for letter E, I have shaded 2/3 of the fraction bar. So 2/3 means I need this to be divided up into 3 pieces. My denominator tells me how many equal pieces the whole amount's cut up into. And if I want to shade 2/3 of this, that means I'm going to shade 2 pieces, because that's 1/3, and one more is 2/3. All right, letter F, shade 5/8 of the circle. So for 5/8 of this circle, that means I need this to be broken up into 8 pieces that are the same size. So I'm just going to start with 4 pieces. And I'm going to draw a few more lines in, one across here, one across here. And now I can see that I have 1, 2, 3, 4, 5, 6, 7, 8 pieces. To show 5/8 shaded, that means I just need to choose any 5 pieces. They don't have to be the same ones I chose. Any 5 pieces will be 5/8 of that circle. So that's how we represent fractions. All right, moving along to one more little review section here. I have unit fractions. And if you are trying to remember what is a unit fraction exactly, it is a fraction that has a numerator of 1. So the numerator is equal to 1. And I don't know if you recall seeing this in class. You might. I made a diagram that shows a whole bunch of unit fractions, and I can't get the entire thing to appear on the screen at one time, so I'll kind of move it up a little bit. But we had filled this out in class together. And this right here, the top bar, this represents one whole amount, okay? Now, this second set, I broke it up into 2 pieces. So because it's broken up into 2 pieces, my denominator is 2, and each of these is 1 piece. That 1/2, that's a unit fraction because the numerator is 1. And off to the side, if you notice, I have 2/2 equals 1. If I have 1/2 and another 1/2, I now have 2 halves. And 2 halves would mean this whole bar would be shaded, so 2 halves is equal to 1. For the next one, I divided this bar up into 3 pieces. So each piece represents a third. And if I have all 3 thirds, that means I would have 1 whole bar. Now I have 1/4. It's cut up into 4 pieces. This 1/4 that's highlighted here, that's the unit fraction. Its numerator is 1. If I have 4/4, if I have all of those pieces, that would mean I'd have the entire bar. Same thing for 5ths, cut up into 5 pieces, 6ths, 7ths, 8ths, 9ths, 10ths, 11ths, and 12ths. And if you notice, as we go, as my denominator gets larger, the pieces get smaller. That was something we spent some time talking about in class. We kind of spent a lot of time talking about that. It's a really good pattern to be able to identify because it's going to help us to compare fractions. But basically, every time I increase my denominator, the pieces get smaller, and the reason is it's because we're dividing up the whole into more pieces. So think about it. If you had to share, if this was a candy bar, here's one whole candy bar. If you had to share that candy bar between you and someone else, that's how big of a piece you would get, right there. If you decided you're going to share that same whole candy bar with 3 people total, you're going to get a smaller piece because you're breaking up the whole into more pieces. If I'm sharing with 4 people, I get a smaller piece. If I'm sharing with 5, a smaller piece. So that denominator tells me how many pieces the whole is being broken up into. The more pieces I cut the whole up into, the less you're going to get. So that's a really good pattern to be able to see. And also, I'm hoping that you notice along the side that every single one of these, when the number is over top of itself, is equal to 1 whole. That happens every time you have a number over top of itself, because it's saying that you have all the pieces. If you have 7 out of 7 pieces, you have the whole candy bar. If you have 8 out of 8 pieces, you have the whole candy bar. And also, if you connect this back to division, when you divide a number by itself, 2 divided by 2 is 1. 3 divided by 3 is 1. 4 divided by 4 is 1. Fractions are like little division problems as well. So you can use that pattern here to help you when you're comparing unit fractions, which is what I'd like to do. And we just have 3 little examples left and we'll be done. The first example I have here, and again, try to do this on line paper, or if you have a whiteboard and marker, you can do those, you can use that as well. But honestly, you can just use regular paper, scrap paper, whatever you have. Try these on your own. You can pause me and then check your work. So for letter A, I have 1/7 compared to 1/9. Now maybe you're thinking, oh, I don't know, well, 9 is more than 7, so wouldn't 1/9 be greater? If you look up at your fraction bars here, here is 1/7. Here is 1/9. Which one takes up more space? 1/7 does. That means 1/7 is greater than 1/9. Here I'm sharing with 7 people total. Here I'm sharing with 9 people. I'm going to have a bigger piece if I only have to share with 7. So when you're comparing unit fractions, when you notice that, hey, both of these fractions have a numerator of 1, the fraction with the lower denominator will actually be greater because the pieces are bigger. You could always look back up to this chart as well if you forget, or we could just draw a diagram of that if we didn't have that chart in front of us. Right, for letter B, I have 1/2, 1/8. Think about this. Here, I'm sharing a candy bar with me and my friend and I. Here, I'm sharing a candy bar with 7 other people and myself. Which pieces are going to be bigger? Well, definitely having 1/2 of a candy bar is going to be more than having 1/8 of it. And letter C, 1/10 compared to 1/4. Again, these are unit fractions. If I only have to share with 4 people, I'm going to have bigger pieces than if I have to share with 10. So 1/4 would be greater. And just to let you know, there is going to be a copy of these notes linked right on the Weebly page. So you'll be able to look back to these notes. You can print them out, or you can just look at them on your computer or on your phone, whatever you're using to look back to this lesson. I hope this helped, and good luck on your questions that you answer after this. Miss you guys.